it going, you guys? In this video, we're going to be talking about section 4.1, which is really just dealing with inverses. So first thing here, when we think of inverses, inverse just kind of means like the opposite. It's going the opposite direction. For functions and relations, it means the exact same thing. So like, you know how you can usually put in an x value to get out a y value? We're going to switch x and y where they are, so that really we're putting in a y value and getting out our x value. So it's kind of determining like, if I want my output to be this, what do I need to make my input? Just helps solving equations a little bit easier sometimes. So a few characteristics of these. Inverses switch x and y exactly where they are in the equation, and then we can resolve for y to actually figure out what the inverse function is. If the original function is f of x, the inverse is notated with this f to the negative 1 of x. That just means the inverse function. Also, if f of x and g of x are both inverses, the following will be true. F of g of x will be x, and g of f of x will also be x. So think about, I think it was unit 2, and we did composition of functions. If we do composition both directions, f of g and g of f, or f of f inverse and f inverse of f, they will both simplify to be x. That's a way to check to find that we're actually finding the inverse functions. All right, so now let's get into actually like finding the inverse functions. So, and I think they also, we'll get to that in a minute. I think we're going to graph some inverses here in a minute. So find the inverses of each. So notice, this says f of x. Don't forget f of x really means y. So if I have y equals x minus 4, to find the inverse, we switch x and y exactly where they are. Do not change anything else about the equation. So this becomes x equals y minus 4. Then to find the inverse, all I'm going to do is resolve for y. So if I add 4 to both sides, plus 4, then I have x plus 4 equals y. So that is my inverse function. Now, notice the original was notated with f of x. So my inverse is going to be f inverse, so f to the negative 1 of x equals x plus 4. That is my inverse. That's really all we're doing. So switch x and y exactly where they are in the equation, and then resolve for y and rewrite it in inverse notation form. All right, so with part B here, if I switch x and y, don't forget that f of x just really means y. So this is like y equals 6x. So if I switch them, then this becomes x equals 6y. Notice the 6 stayed in the exact same spot. I'm only switching exactly where x and y are, and then I'm going to resolve for y. So in order to solve for y in this, I need to divide both sides by 6. So divided by 6, divided by 6. So that makes 1. So I have y equals x over 6, or 1/6 x. But again, the original is named f of x, so I need to say f inverse of x equals x over 6. That will be our inverse function. Moving on to part C, same idea. I need to switch x and y where they are, so I'll have x equals 5y minus 7. Now I need to resolve for y. So same way that you would solve for something, I need to add 7 to both sides, so I have x plus 7 equals 5y, and then I can divide everything by 5. So divided by 5, divided by 5. So f inverse equals x plus 7 over 5. Don't forget that Apex is kind of tricky sometimes, and they will try to say that this is 1/5 x plus 7 over 5. You could see it as that as well. So don't let Apex trick you. These both mean the exact same thing. All right, moving on, doing good. So we have f of x or y equals 4x plus 9, so switch them where they are. Do not change anything else about it. So now this is 4y plus 9. Notice all I did again was switch the x and y exactly where they are in the equation. Now I'm going to resolve for y. So I can subtract 9, so I have x minus 9 equals 4y. And then divide everything by 4, so divided by 4, divided by 4. So y equals x minus 9 over 4, or f inverse equals x minus 9 over 4. That's probably how I would like to see it written. All right, moving on. Now, notice we have a cube in there. So this doesn't really change that much. Still, exactly where they are. So y equals 2x to the third plus 7. So I need to switch x and y exactly where they are. Do not change anything else. So notice that cube still stayed where x was, because now that becomes a y. So I need to solve for this in the same way we were solving all of these. So I have x minus 7 equals 2y to the third. Then divide both sides by 2, divided by 2. So I have x minus 7 over 2 equals y to the third. Now to get rid of that third, just like we get rid of a squared with a square root, to get rid of a cube, we need to take the cube root of both sides entirely. So this becomes f inverse of x equals the cube root of x minus 7 over 2. All of that is inside the cube root. All right, moving on. Switch them exactly where they are. So x equals square root y plus 4 minus 5. So the first thing I will do is I will add 5 and add 5. So I have x plus 5 equals the square root of y plus 4. Then to get rid of the square root, the opposite or inverse operation is to square both sides. So I'll leave this x plus 5 squared equals y plus 4. And then I can just subtract the 4 from both sides. So I have y, and I'll go ahead and write f inverse of x equals x plus 5 squared minus 4. You can leave it just like that. But remember, sometimes Apex will want you to multiply this out. So make sure you take the time and actually multiply x plus 5 times x plus 5 to get x squared plus 10x plus 25, and then minus 4, so x squared plus 10x plus 21, and go from there. All right, moving on. Same sort of idea. Switch x and y exactly where they are in the equation. So I now have x equals 3y minus 7 over 4. Then, check it out. To get rid of this fraction, I can multiply both sides by 4. So I now have 4x equals 3y minus 7. And I'm going to keep doing the same process. Add the 7 to both sides. So 4x plus 7 equals 3y. And then you can divide both sides by 3. Divide everything by 3. So I have f inverse of x equals 4x plus 7 over 3. That would be my inverse equation there. All right, getting too close to the end. So with h here, again, I know I've been saying it for the first, like, I don't know how many we've done so far. We're on letter H, but I've been saying it all through. Switch x and y exactly where they are. So I now have x equals 3y over 4 plus 4. So take your time. Think about what could help you first. I would probably subtract the 4 so that we get x minus 4 equals 3y over 4. And then I would probably get rid of the fraction, so I'd multiply everything by 4 so that this becomes 4x minus 16 equals 3y. And then I would divide everything by 3. That's the process I would take. You don't have to follow that process, but I think it's the easiest for you guys to understand. But again, as always, if you guys don't understand something, just email me. I'm only an email away. I'm looking forward to helping you guys, so please, 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 let me help you. All right, that was that one. So again, f inverse notation, 4x minus 16 divided by 3 to get rid of the 3 right there. All right, look at that. We only got 2 more. So with I, we're just finding the inverse, yeah? Okay. Switch x and y exactly where they are, so I have x equals 3 times the fraction y plus 3 over 7. So there's a few ways to go about this. What I would do if it were me is I would probably multiply both sides by 7 to get rid of that fraction so that we have 7x equals 3 times y plus 3. And then what I would do is I would divide by the 3 to get 7x over 3 equals y plus 3. And then you could just subtract over the 3 and be done with the whole equation altogether. You could have divided by the 3 first, and then multiply by 7. It's going to get you the same thing. But to me, again, I'm just trying to do it the easiest way I think. But if you think something else is easier and it makes sense to you another way, by all means, go ahead. As long as you are coming out to that in the end, it's perfectly fine. All right, so determine the inverse of the mapping. So what is happening here is this is our domain, this is our range. Don't forget the domain means the x values, the range means the y values. So if I am just switching the x and y every time I have an inverse, the inverse mapping would now be the domain. This is the inverse. The domain would now be 9, 10, 11, 12. And the range would be the 6, 7, 8, 9. And we'd have 9 to 6, 10 to 7, 11 to 8, 12 to 9. That would be your inverse mapping. You're just switching the x and y exactly where they are in the equation. Same thing all the way through. So for the domain and range is given to us. Again, all we're doing is switching the x and y's. So again, the x's are the domain right now, the range is the y's. For our inverse, the domain is now the range of our old one, so negative infinity to 6. And the range is the domain of our original, so 3 to infinity. And that's it. So inverses, moral of the story, inverses switch x and y exactly where they are. Don't forget about this, this right here, f of g of x equals x, and f of f inverse and f inverse of f equals x. Apex is going to ask you, is this true? Can this happen? So just make sure you guys refer back to your notes. It's true. All right, I think that's it. So please email me. Let me know what I can do to help you guys out. I look forward to answering your questions. All right, I'll talk to y'all soon. Bye.